Alright, this is the start of the third video for the TEKS review. We're going to start this page off with solving absolute value equations. If I need more room, I got some extra paper around here that I'll start using. So if I pause, that's what I'm trying to grab. What we're going to do first is we need to get this absolute value part by itself. Actually, let's go ahead and grab a sheet of paper. Absolute value by itself, so we're going to go ahead and we're going to add 2 to both sides on this one. So we get 3, absolute value of 4x minus 5 is equal to, when we add 2 on both sides, this is going to be 21. Then we need to divide by 3. 4x minus 5, absolute value of, divide by 3, and that's 7. Now that we have our absolute value by itself over here, we're going to say 4x minus 5 is equal to 7, and 4x minus 5 is equal to negative 7. Those are our 2 different ones we're going to do. Then we're going to solve each of those. This one we're going to add 5 to both sides, so 4x is equal to 12. Then divide by 4, x is equal to 3. This one over here, we're adding 5 again. 4x is equal to negative 2. And then we're going to divide by 4. Negative 2 divided by 4 is going to be negative 1/2. That's my solution for the first one. And if you want to graph that, well, you just do it at 3 and 2, 1, 0, negative 1/2, if you want to graph that. This one over here is an inequality. Let's go ahead and see what that looks like. We have to get the absolute value of x by itself. Subtract 2 from both sides. Subtract 2, so we get 3. Absolute value of x is less than or equal to 3. So when we split this, x is going to be less than or equal to 3, and then we got to flip both signs. X is greater than or equal to negative 3. So x is less than or equal to 3, and x is greater than or equal to negative 3. What that looks like, let's go ahead and just mark this 0, 1, 2, 3, 1, 2, 3, negative 3. So I have negative 3 and 3. The equal sign on the bottom line says these need to be filled in. And I'm going to go to negative 3, and this is greater than, which means that's shade to the right. And this is shade to the left, so shading that way. My solution is between and inclusive negative 3 to 3. Okay, next one, number 11. Record the solution set on the number line. So we're going to go ahead and solve these. Drop it in on the number line. So it's already solved for us here, so we need to split this up. Let's go ahead and split it. X plus 3 is equal to 4. X plus 3 is equal to negative 4. Positive and negative 1. Subtract 3 from both sides. X is equal to 1. X is equal to, subtract over here, negative 7. So we have 1, 2, 3, 4, 5, 6, 7. Not sure why. Oh, sorry, this is negative 7. That's why that makes sense. So let's go ahead and, make this 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. And then if I look, it says what's the distance between negative 3? So this is 1, 0, negative 1, negative 2, negative 3. it's 1, 2, 3, 4 away, 1, 2, 3, 4 away. So in the parentheses, there's your negative 3, what they're talking about here, and my distance is 4 away. Then next one, same equation, or same absolute value equation, except we have a negative in there. Let's go ahead and solve that. Pretty straightforward and simple. We have x minus 3 equals 4, x minus 3 equals negative 4. X here equals 7, x here equals negative 1. So here we have negative 1, 0, 1, 2, 3, 4, 5, 6, 7. Okay, and it says how far is each distance from 3? Positive 3 here. 0, 1, 2, 3. And then we're 4 away here, 4 away there. Number 12, identify the following for the graph. What direction does the parabola open? Pretty easy. If it's positive, it opens up. If it's negative, it opens down. That's positive in the very front, so it opens up. What is the equation for the axis of symmetry? Equation for the axis of symmetry is negative x equals negative b over 2a. Negative b, so we have negative, and we have b is 10 over 2a. A is 1, so that's negative 10 over 2, which that is negative 5. It has to be x equals because all axis of symmetries are lines. They're vertical lines. X is equal to a number. 13. Certain forms of quadratic functions tell us different information about the graph. Complete the following information. Which way is this going to open? This is going to open up. It front's positive. Opens up. My intercepts, well, I set each of these equal to 0. Should be pretty straightforward and simple. No fractions here. That's going to be positive 7. And that's going to be negative 5. Just change the signs in there. This one opens down. It's a negative equation. Sorry, yeah, negative in a value. Y-intercept is going to be 30. That's this over here. This last one in standard form. This is factored form. This is standard form. And this is vertex form. This opens up. Again, it's a positive equation here. A value out here is positive. My vertex is negative 2, 6. This is my h and k, and the vertex is h and k. And the reason that's negative is because this is a negative. Everything in the parentheses is opposite. Domain of h of x. Domain for all these is always all real numbers. And the range, well, it opens up, so it's some number and above. So that number is on my vertex, the y value of my vertex. So it is inclusive with 6 and goes all the way to infinity. You could also write that as y is greater than or equal to 6. Those say the same thing. Alright, last one on this page. We're going to use regression to find it for this quadratic data. This is quadratic data. You could also graph these and look and see which one you should choose. This goes ahead and tells you it's a quadratic. To put the data in, we type in stat, and we're going to go. The first thing we're going to do is edit. We're going to edit. So we're going to edit here. We're going to go ahead and clear these. If you go up here and press clear, enter. Go up here, clear, enter. We can start typing. We do my x's, then my y's. 10 enter, 8 enter, 13 enter, 9 enter, 11 enter, 14 enter, 6 enter, 4 enter, 12 enter, 7 enter, and 5 enter. That's fun. Y's, we go 9.14, enter, 8.14, enter, 8.74, enter, 8.77, enter, 9.29, enter. 8.1, enter. 6.13, enter. 3.1, enter. 9.13, enter. 7.26, enter. 4.774, enter. Then I'm going to quit that, and I'm going to go to stat, and I'm going to calculate, and I'm going to do a quadratic regression. Again, I'm going to show you, you don't have to on this one, but I'm going to show you how to store that in Y1. Store regression, press Y bars. It's this key right here. You're going to go over to Y bars, and we're going to choose function, and we want to put it in Y1. So it says we're going to put it in Y1 right here. Quadratic regression. There's my equation right here. That gives me A, B, and C. It even tells you where to put A, B, and C. We have negative 0.127 x squared plus 2.785 x minus 6.0128. You can be as exact as you need to be for this right now, as long as you know how to get it. And the whole storing thing, this is how what we did it for. If I look in my Y1 now, you'll see that whole number put in here. And there's that A value, x squared. There's your B value, and then an x, and then there's that C value. And here's what the graph looks like. Let me go ahead and zoom standard if it shows up there. There we go. There's part of it, and you can now look at the table as well. I'll save this for another video.